Okay folks, I hope we're all enjoying homeschooling. Let's look at today's maths challenge. Just to recap the rules, Wednesdays, Fridays, 3 questions each time, and answers by the end of the day. I'll say end of the weekend for the Friday one, with these being the marks. I put up a leaderboard next week. First off, let's look at the questions from last Wednesday. So the first one I think looks a lot more complicated than it is. What you've got to start off with looking at is these triangles here. They need to be 1, 1, 1. You can't add 2-digit numbers and 1-digit numbers and get anything any bigger than that. That means that the circles are either 88 or 99. You do a little bit of a trial and error here, and it turns out that 99 is the one that works because you can add 2 lots of 6 to it. Check that works, yeah. 6 plus 6 plus 99 gives 111. Going back to the actual question, that means that 9 plus 6 plus 1 gives us 16. Now for the second question, there are 2 ways you can do it. You can do a sort of trial and error approach. We can just pick some numbers. We can do all of these instructions over here to them, and we can see, well, what's the biggest number I could actually pick that I end up with a 2-digit answer. But we can be a bit smarter about this. In maths, if you're told about a number you don't know, you just generally call it x. So if we want to multiply it by 5, we now have 5x. If we want to take away 30, we now have 5x take away 30. If we multiply that by 3, well, the 5x goes up to 15x, and the 30 goes up to 90. And if we want to take away another 10, that minus 90 now becomes minus 100. Now, if we've got some algebra here, and we're saying this is a 2-digit number, well, what's the biggest 2-digit number we could actually get? It'd be 99. So we'll set up that equation. 15x minus 100 equals 99. Add the 100 across, divide by 15, and then because it's a whole number we had to start with, it'll be 13. Either way, trial and error or this slightly clever algebra approach should get you to 13. Third question also looks quite complicated, and you might be tempted to reach for the pi r squared because we're talking about circles area, but we can actually just count each of these chunks of circle at the corners of the square, because it says it's going through the center of the circle, are just quarter circles. So we've got 1, 2, 3, 4 quarter circles there. We've also got a whole circle in the middle. So the shaded area is just 2 circles. It's 4 lots of a quarter plus 1. The unshaded circles, well, there's 3/4 of a circle here, another 3/4, another 3/4, another 3/4. We've got 3 full circles there. So the ratio is as simple as 2 to 3. Anyway, with that out the way, let's have a look at today's questions. First one, you just need to find the value of x here. We're told the value in each circle is equal to the sum of the 2 circles below it. So these 2 circles here should add up to 15. The second one is a case of counting squares and triangles. We're not just talking about little triangles like this, we're talking about all triangles of all sizes. How many triangles, how many squares are there on the diagram? And the last question's a little bit trickier. Each of those equilateral triangles you can see has an area of 4. So my question is, what is the shaded area on that diagram? Now bear in mind, you don't need to answer all 3 questions to enter. Any answers will count towards the leaderboard. I look forward to getting your responses. Don't forget, answers in to the same email address as before. End of the weekend, we'll say. Have a good day.